Hey, what's going on, folks? It's Mike here, and welcome back to my D programming language series. In this lesson, I'm going to take you to school. We're going to be talking about classes. Alrighty, so with that bad joke out of the way, let's go ahead and dive into the D language website here and check out classes in the D programming language. Now, for those of you who have been doing some programming here, if we go to language reference and down to classes, you'll realize that this is a huge part of object-oriented programming. We've, of course, talked about structs, which are a way to create our own user-defined type and have an object of sort, but really, when we talk about object-oriented programming, we're talking about classes. And this is going to be an important distinguishment in the D programming language here, but let's go ahead and start from the top, learn what a class is, or refresh it for those of you who already know here. So what I'm going to go ahead and do here is I'm going to minimize this page just a little bit here and give you the forewarning that we are going to talk about this in multiple videos. If you want to subscribe or otherwise track your progress on courses.mshot.io, let's go down to the D page here. Then we'll go through all the classes lessons here as I post them, and we'll talk about many of the topics listed here. But again, just want to talk about the basics of a class here, and we'll take some notes along the way here. In fact, let's get up the notepad. Here it is, and talk about classes. So, as noted here in a reference, the object-oriented features of D come from classes. So this is going to include your classic things that you might have learned about in school, like how to put the data members with the actions, the behaviors, or the member functions, ideas of isolation, encapsulation, even other ideas that I think folks forget about when we talk about object-oriented programming, like message passing or having objects talk to each other. That is something that we can do in the D language, which is really, really nice. But anyways, let's go ahead and dive into at least some of the basics today and just see how classes are different than structs. So that's going to be the main thing that we want to answer in today's video. So the first thing to highlight is, again, a class is a way to create a new data type. Okay, so similar to structs in that we could create a new data type, class also allows us to do it. Now, the distinguishment here is that we have a hierarchy here. So what that means, and I'll go ahead and draw this out, we have this object. Let's do it in a different color. There we go. At the top of this hierarchy, and then we have our derived type from object, which would be our new type. Let's just call it, let's do animals in this example. Let's say cat or something. So cat is a type of object. We can see it in this hierarchy here. So classes utilize inheritance. And in D in particular, this is going to be single inheritance. So I'll just put a little bullet down here. Single inheritance. So if you're coming from C++, maybe you're used to multiple inheritance, but that can sometimes cause some complication in the code. So D went the same route as Java, for instance, and we have single inheritance. Now we do have things called interfaces. Again, we'll go ahead and get to those in later lessons, so we can check those out when the time is available here. So we have this special object class that we derive all of our new types from. If you're just curious where that is, I'll go ahead and show you. If you want to go to the library reference here, and you'll see it just at the very top here, object. Okay, so I'll keep that tab open just if you want to go ahead and take a look at that. But that is sort of the base type when we have classes that we can inherit from here. Okay, so anyways, let's go ahead and resume our journey talking about classes. So that's sort of understanding the next few sentences here about this mysterious object type that we derive all types from. And that's just sort of implicit anytime that you create a class. So just keep that in mind. Most of the time, like today, we're just going to look at creating a new data type, but you can have that in the back of your mind just so you know a little bit about what's going on here. So again, classes are a programmer-defined type. We know that, just like structs. And again, in D, this is our tool for all the object-oriented features that you might have learned about in school or just learning about now. And again, as mentioned, D supports single inheritance here, and we can have multiple interfaces. However, so again, if you're coming from a Java background or C#, you're going to find classes very, very familiar. If you're coming from a C++ background, things will be just a little bit different here. Okay. All right. So with that introduction out of the way here, let's just go ahead and scroll through a few of these things here. I'll actually just give a few tips here, and we'll take a few notes here. I mean, let's just start with the basics here. Let's go ahead and create a class type here. I'm going to use animals for this lesson, like cat, for instance. And this is going to compile just fine here if we run this. Again, this is the syntax here. So there's no trailing semicolon, again, if you're coming from a C++ background, so you don't have to worry about that. Again, it basically mirrors the same thing as a struct here. Now, some of the differences here, and let's just go ahead and label this as cat class versus if I were to make this a struct, cat struct. I do want to just highlight here because I think these are some of the important differences to keep in mind. So let's go ahead and just make another little bullet here. Classes are not equivalent to structs, okay, in Dlang. Okay, so that's something that might take a little bit of getting used to, but again, if you're coming from like C# or something, this is going to be a familiar model here. So what do I mean by this? Well, let's go ahead and give our cat some value here. Let's say they're, I don't know, meows or something here. Let's do the same thing for our cat struct. Oops, let's give it the meows field here. So I don't know, we're counting how many times a cat meows or something. So anyways, the thing that I want to distinguish here is that a class is a reference type and a struct is a value type. Okay, so that's the first distinguishment that we need to make here. And because we have a reference type and the other features of a class here, so other features of a class can use inheritance. We can call this dynamic, dispatch or polymorphism. Okay. Can be overridden, inherits from the object .d type here, object, okay? So again, these are a few of the things that are a class here. But what does it mean if something's a reference type? Well, you get all these different things, and a struct basically is a collection of data and a collection of member functions. Okay, that's all it is versus a reference type. So a reference type for our class here means it's carrying around a little bit more information. So let's just kind of see how these are used a little bit differently here. And let's just go ahead and create a function here. I'm going to call this let's just call this func1. That's going to take in a cat class C. And it's going to set the meows equal to 50. And let's create another function here. Func2, this is going to be the cat struct. Let's call it C as well for the cat. And the C meows equals 50 here. Okay. Now, one thing that you might wonder about is, does this code compile? Okay, so let's go ahead and compile it here. And it does. So another thing to add to our list here, and you can add this for both classes and structs, members are public by default. Okay. Members are public by default. And if you've been watching this series when we talked about structs, I probably mentioned something similar. And again, that's going to be something that's new in C++. Even if I make this a private variable, it'll still be public within this module, so within this main.d file here, which again might take a little bit of getting used to. And the fix is easy if you do want that private or that sort of encapsulation. It's just you put this in its own separate file, no problem there. And I know that's a little bit controversial, but my sort of opinion about it is, well, if I can see all the source code, why is this thing being hidden from me? Or at least that's, I think, part of the rationale, at least in the D language and perhaps other languages that make that choice. So again, just something to think about here. So anyways, that's why we can just access this value here. Again, so if you're in a C++ mindset, this is, again, not going to be or what rather you're used to is having privacy by default, but in D, things are public by default. So you could basically type out your access specifiers like this if you want, but it would be completely redundant. Okay, so let's go ahead and get rid of that though for now. And let's go ahead and use these functions here. So I want to go ahead and create a cat class here. I'm going to call this cat one class equals new cat class. And let's go ahead and create our cat struct here. And I'm just going to create this as cat1. Let's do cat2 struct. Okay. Now, the first thing that you'll notice here is I've used new here. Okay, so let me add a comment here. Classes in D must be, well, let me say this, 99.99% of the time are heap allocated, okay? So you use new with a cat class. Now again, I say 99.9% of the time because there's always a way in programming to do something different. So again, for those of you who are advanced, if you want to look at the core and lifetime, I think is a place that you could do it here. Let's see if I could find the module here. You could use in place here, and it allows you to, you could copy basically a class into a stack allocated piece of memory here. Okay, but anyways, I don't want to get too much into that, but again, classes just for the most part default and must be heap allocated. Now structs of course can be heap allocated. We can do this equals new cat struct, right? And then I need to make this a pointer. So again, that's just the thing to keep in mind here. So I'll keep that as a note here. Let's see, can heap allocate structs, but let's go ahead and scroll down here. By default, structs are stack allocated. Okay? So again, the decision is yours with a struct, but with a class, it's basically, it's on the heap, and then that means it's going to be garbage collected by default here. Okay, so what's that mean? Classes are typically then garbage collected. So you can think about them. Again, you don't really have to manage the memory here. And we'll talk about constructors and destructors in this future lesson later on here. Okay, so those are a few of the basics here. Now let's actually call our functions here. So func1, I'm going to pass in cat1 class. Func2, I'm going to pass in my cat2 struct here. Okay, so just matching the function signatures with each of these. So func2 takes in a struct, func1 takes in a class. So that's what we've got here. And then let's go ahead and just add standard input output here. And let's go ahead and write out what we think cat1 class.meows is going to be. And we'll do the same thing for cat2 struct. Let's see how many meows there are. And again, just to keep this in context, here's our functions here. Okay, so I'm going to go ahead and run this here. And you can pause the video and make your prediction here. But again, I'll give you a little hint. Cats are a reference type. They're on the heap. We've heap allocated them. And structs are value types. Okay, so let's go ahead and run this. And what do we get? Well, our class here, since it's a reference type by default, has changed its value. Okay, and structs, since they're a value type, that means I'm passing in a copy and changing the value. Okay, so a reference type, heap allocated, so that means I'm passing in a reference to the exact cat class, cat1 class in here, and changing its member variable, thus it's changing this function. For func2, it's stack allocated, or it's a value type that's stack allocated. So that means when I'm passing in this copy here, I'm only changing the copy and not the actual struct here. And you could prove this to yourself by printing out the address of the struct here. And let's just go ahead and do that here just to be super, super clear. It might make it a little bit of a longer lesson here. But let's go ahead and just do it anyways. So let's do cat2 struct address in main. Okay. And I'll take the address here, cat2 struct. I might need to cast that to a pointer to print out. Nope, that's going to do it here. Okay, so we can see the address there. And then let's go ahead and do the same thing in our func2 here. And this is just going to be C. And let's do this again for our class here. And let's go ahead and do it. Let's go ahead and print out our cat1 class here. Cat1 class address. And I'm going to put just one little, I'm going to sprinkle in a few right lines in here just so we can make this a little bit cleaner here. There we go. Okay, so let's go ahead and run this and study our program just a little bit here. Let me go ahead and do one little change here. Let's go ahead and label these, sorry, just so we're super, super clear here. This is going to be in func1. This is going to be in func2. And let's line up the colons here just so we can see the addresses. Okay, there we go. Okay, that's a little bit better. So what we can see from this analysis, and we'll build on this just a little bit here, is again, in main, we've got a unique location for our class. In our struct, we've got a unique location for our struct. And then in each of these functions here, I'm just passing in some stack allocated value here, okay, in func1 and func2. And you'll see that these are actually the same values, whatever they are. I mean, in this case, it might happen to be this was some like pointer or some value, but that's what's being passed in here. But again, the behavior is going to be a little bit different here. And again, we can investigate this by looking at the type ID of the thing that we're passing in. So let's go ahead and do that here for both of those lines. Rerun it again. And again, this is a cat class and a cat struct. So classes, again, have reference behaviors. That means it's going to change behind the scenes, whatever at this address it's pointing to. Okay, so when I'm passing in a reference type, it's effectively like passing by pointer. Okay, so you can kind of think of it that way here. So even though, you know, these addresses are getting reallocated on the stack here, it is, or what I should say, what matters is the underlying type here. Okay, because we're passing in a reference type here. Now, again, if you do want to change the actual structures here, for cat struct, let's just go ahead and start with that one here. I'll rerun this here. And now we should see func2 here is actually modifying for the struct here, because we're using reference semantics, similar to what we have with classes, but then class gets that reference semantics for free, effectively. Okay, we'll talk about what ref means on a class here in a second here. But again, if we just focus on the struct example, this is a little bit of a reminder, the address that's being passed in is the same as the address of the struct here. Okay, now this is just whatever argument happens to be here for func1. Again, it's different than our actual class type here. But let's actually now change our cat class to have a reference type that we're passing by reference. And then what we should see here is, again, same rules with ref. It's kind of like we're just copying and pasting whatever we find in main into our function. So you can see the last digits match there. And the same thing for our struct, which we're also using reference semantics. It's kind of like just pasting in whatever that type is here as well. Now, what does ref do on a class, for instance, which is already a reference type? Well, this basically allows me to, if I were to reallocate this object and do like equals new cat class like this, this would actually change what this object points to. Okay, and the default value, let's go ahead and run this now, you'll see is 0 for the cat class here. Why? Because I've pointed this reference type, which is referencing the actual thing in main, to a new chunk of memory, which has meows. If we scroll up here, well, it's default initialized to 0. Okay, so that's the idea there. Okay, and if I were to otherwise, let's go ahead and leave this in, remove this ref here. Let's see what happens. Well, it's still 50 because I'm not passing in. I'm passing in a pointer, which is changing the underlying data of the class, but I can't change what I otherwise point to because it's a different object or memory location here. Okay, so we still preserve meows at 50. So this might be a little bit to digest here, but this is one of the primary differences between reference types and value types, or otherwise references. Reference type being a class and a struct here. Okay, so what kind of semantics do we otherwise want? Okay, so let's just do a little bit of a brief code review here. And then in the next lesson, we'll again try to motivate a little bit why would you choose a struct versus a class, and again, the repercussions of this design choice, okay? So anyways, we created a class here called cat class and the equivalent of a struct. And our goal was to say, basically with classes, we get a whole bunch of extra features here. We can override functions, we could do inheritance, all these different features here. But a struct is just a plain old value type here where we can kind of group together some related variables and member functions here. That's basically all a struct is. But a class gives us all this power here. Now, of course, with that power, we have to be responsible. We have to consider how we are going to now heap allocate this thing, or folks might derive a new type from this, and all these other things that we're going to talk about later in this series. But the main point of this video was to, again, go over the reference versus value semantics of how we pass a reference type, like a class, versus a value type here. Now, structs, it's pretty simple, right? We can still just pass things by ref. We could pass things by pointer. But again, ref is basically copying and pasting that thing here. And with a class, sometimes folks will get confused here. So I'll just go ahead and put the little note here. It says, if we pass by reference, we could basically, if we pass by ref keyword. So let me actually type this out more clearly. If we pass a reference type, i.e. a class, by ref, then we will allocate a new object for that type here, okay? If we don't pass with ref, this effectively does nothing, okay? Other than, I guess, if we use this object later on in the function, it might, we could use those values, but effectively how this is set up here, it doesn't do anything. This effectively does nothing in the sense that the change will not persist outside of this function, okay? So that's the basic idea here. And we did some experiments with just printing out the address of class and the address of struct to try to understand this. And we also talked about how classes must be heap allocated 99.99% of the time. That's how I'm using them. There are little tricks that you can use to stack allocate a class type if you wanted, but that might be a code smell in some ways. But and then otherwise, we just saw through our little brief summary what a class is here. Okay, so just another tool for creating different types here. Oops, let me leave that open here. It allows us to do things like inheritance, use dynamic dispatch and polymorphism and all these things here. But the important part is that classes are not equivalent to structs. They have different semantics. Classes are a reference type and structs are a value type. So I'll keep pounding that into you just so you make sure you remember that here. Now, this might not be the easiest introduction into classes and structs in that sense, but we're going to wind back in the next videos here and just kind of do the same thing with the struct and just say, here's a struct and here's a class, and let's add some members, add some member functions, and you'll have the basics there. But anyways, this is the important stuff that you have to know, otherwise how underlying things work here. So anyways, folks, with that said, that's your technical introduction, I suppose, to classes and the mechanisms of how they work. And otherwise, just making sure that we keep track of reference types versus value types. Now, we've already seen some of these things that are reference types, like maps, for instance, or our dynamic arrays. And again, we can think about what happens when you pass those into functions. And again, now we can kind of see or maybe understand some of those semantics now that we know what a class is. So anyways, folks, with that said, as always, I appreciate your feedback. I'll look forward to your comments below. And as always, again, thank you for your time and attention. We'll see you in the next one.